Hello, Accelerated Chemistry students. This is Miss Crystal Foley, and this is your Chapter 6, Section 1 video notes all over how we organize the elements in the periodic table. So let's first start talking about how they searched for an organizing principle. So a few elements, including copper, silver, and gold, have been known for thousands of years. That makes sense. There were only 13 elements identified by the year 1700. And chemists are very intriguing creatures because they suspected that other elements existed. And so, as they began to use scientific methods to search for elements, the rate of discovery increased. So, in one decade, remember, a decade's 10 years, chemists discovered 5 new elements. So now we're up to 18. Anton Lavoisier, from 1743 to 1794, compiled a list of known elements. By this point, there were 33 of them, and organized them into 4 basic categories: gases, metals, nonmetals, and earths. The number of elements vastly increased in the 1800s due to the advent of electricity, the development of the spectrometer, and the Industrial Revolution in the mid-1800s, which led to many new chemistry-based industries. So early chemists used the properties of the elements to sort them into groups. This is a chart that shows how the original were sorted into different groups. John Newlands in 1864 organized the 70 elements in increasing atomic mass. He noticed that the properties of the elements repeated every 8th element. And by definition, a repeating specific pattern is called periodic. So his repeating of every 8 elements, or the properties of every 8 elements, was known as the law of octaves. Octa stands for 8. And so that's where he came up with his repeating pattern, every 8 elements. This gentleman, J.W. Dobereiner, was around in 1829. He was a German chemist. He published a classification system in which the known elements were grouped into triads. A triad is a set of 3 elements with similar properties. So he notes a pattern in his triads. One element in each triad tended to have properties with values that fell midway between one of the other 2. So, for example, one of his triads included chlorine, iodine, and bromine. So, the average atomic mass of chlorine and iodine, if you were to add up their 2 masses and divide it by 2, you would get 81.18 AMU. And bromine had a value for its atomic mass that was very close to that at 79.904 AMU. So those were the early people that came up with how are we going to organize these things that we're calling elements. Dmitri Mendeleev came around in 1869, and he published the first periodic table. Like Newlands, he noticed a repeating pattern in the properties of the elements. So he arranged the elements by atomic mass and also placed elements with similar chemical and physical properties into the same groups. Here's a picture of what his periodic table looked like. Notice that there are some blanks, and these blanks are there because they did not exist yet, or they hadn't been discovered yet. So this arrangement from Dmitri Mendeleev caused 2 problems. Some of the elements were out of atomic mass order because they were more similar to elements within the group that they were placed. And there were gaps, and these gaps represented the undiscovered elements. Patterns of the elements were so specific that Mendeleev was able to accurately predict properties of undiscovered elements. So in 1871, Mendeleev made this prediction about this element Es that we hadn't found yet. He had the atomic weight, density, valence electrons, melting point color, down and down and down. And he made all of these predictions. When we actually discovered germanium, a lot of his predictions were pretty close, if not dead on. And so his way of thinking about the elements and organizing them makes sense. Henry Moseley came around, though, in 1913 and changed how Mendeleev's periodic table was organized. He arranged it based on increasing atomic number, or the number of protons. And this was a result of the discovery of the nucleus and the proton. Then he proposed the periodic law, which states that there is a periodic repetition of chemical and physical properties of the elements when arranged by increasing atomic number. So let's refresh what periods are. Periods are the horizontal rows. There are 7 of them on the periodic table, and they are equal to the number of energy levels that an atom has around it so far. There are more elements in higher numbered periods, so 2, 3, and 4, and so on, because there are more orbitals in those higher energy levels. The properties of the elements within a period change as you move across the period from left to right. So let's talk about groups. Groups are the vertical columns. When elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. Elements that have the same chemical or physical properties or similar ones end up in the same column on the periodic table. So that's how we came up with the periodic table, and that's how it's organized. Now let's go a little more in depth as to what you can find where. So the periodic table are going to be color-coded to classify types of elements. So this periodic table classifies which elements are metals and nonmetals and metalloids. So we're going to discuss each of those in a little more detail. Now, like I said before, there are 3 categories of elements: metals, which make up 80% of the elements, nonmetals, and then metalloids. So let's break each one of these into an individual category and discuss their properties. So let's talk about metals. Metals are malleable, which means they can be hammered in or rolled into thin sheets. They are ductile, which means they can be drawn into a wire. They are excellent conductors of heat and electricity. They have a luster or are shiny. They will lose electrons to form cations, and we'll talk about that in the future chapters. They're solid at standard temperature and pressure, except for mercury. And they have a sea of mobile electrons. And since the electrons are mobile, they will result in a very good electrical conductivity. Now let's talk about metallic character. So metallic character basically describes how much like a metal an element is. So francium is the most metallic. So in theory, the closer you are to francium, the more metallic your element is going to be. And the further away from francium you are, the less metallic your element is going to be. So francium's all the way down here in the bottom. So the closer you are to francium, the more metallic you're going to be. And the further away, all the way up here in this corner, you are, the less metallic you are going to be. So let's talk about metalloids. Metalloids are the ones on the periodic table that are in that green color. They are going to be your semiconductors, which means that they are a good moderate conductor of heat and electricity. They will have somewhat of a luster. They might be a little shiny like metals, but they are brittle like nonmetals. And their main use is that they're used for making microchips. So here are a bunch of your metalloids. And then the last one are properties of our nonmetals. So let's talk about our nonmetals. Our nonmetals are all the way on the right side of the periodic table. They are poor conductors of heat and electricity. They shatter when they are struck with something hard, so that means that they're brittle. They're dull solids, which means that they do not have a shine to them. And they tend to gain electrons to form anions. And we're going to talk about that in future chapters to come. So if we were to summarize the element characteristics, we would look at metals and say that they're malleable, ductile, shiny, excellent conductors of heat and electricity. Metalloids can be in between. And nonmetals are brittle, dull, and poor conductors of electricity. Now, in section 3 of this chapter, we're going to talk about the chemical properties of metals and nonmetals when we talk about low electronegativity and ionization energy versus high electronegativity and a high ionization energy. And that concludes your chapter 6 lesson 1 notes all over organizing the periodic table. And as always, all the information on these Google slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the Textbook Resources CD and pearsonchem.com. Thank you so much and have a good night.